Okay, so integration using partial fractions. So the first thing we want to be able to do is let's rewrite this as x over, can we factor that denominator? What multiplies to give us 2 adds to give us 3. That one's pretty easy. So we'll have x plus 1 over x plus 2 dx. So using partial fractions, and I'm going to use a shortcut method, I want to rewrite this first of all using partial fractions. Okay, just to check progress before you get too far, you should have that set up here, and your next step will be determine a and b. So get a common denominator, and then after you've done that, you want to set numerators equal to one another and solve for a and b. Okay, so this is my numerator set equal to one another. I'm going to use the what I call the shortcut method. What value of x right here would make this term go to 0? -2, good. So first of all, I'm going to let x equals -2 and solve. Okay, so you could check that up everywhere there's an x, plug in a -2. Of course, this term goes to 0, so we will just get 2 is equal to b. Alright, I might be able to squeeze it in over here. I'll say let x equals. So what if I'm trying to find, I want this term to go to 0. What does x need to be? -1, good. So same thing, plug it in and solve for your a. Alright, we'll just get a there. Alright, well now that we know a and b, we could plug those back in here, a and b, and then rewrite our integral. So let's extend this page. So keep in mind, we want to rewrite this using partial fractions, so that's what I'm going to do next. So I'm going to show that my original problem factored form was to evaluate this integral. Now that I have the partial fraction decomposition where a is equal to -1, I can say this term plus, and what do we get for b? 2. And so now I could break that apart and evaluate. Well, what would be, if I pulled this negative out front, I'm just going to have a negative, what would the integral of this term be? The negative out front, I'm just going to have the natural log of x plus 1, right? And then for my second one, I'm going to have the 2 that I could just bring out as a coefficient. And then I will have times the natural log of x plus 2. And what else? Plus a constant. Yeah, almost forgot. Now, we could also, because both of these are logarithmic, we could have properties. It's addition, so it can be rewritten in terms of multiplication. And remember, coefficients out front would be as powers. But we'll just stop right here and know that we can use our properties to just have it in a different format. Okay, our next example. Our numerator is the degree of the numerator is less than the degree of the denominator, so we can use partial fractions. If it was not, we would try long division. Okay, so really what I want you to do is practice taking this and rewriting it using your partial fraction decomposition, and let's just set it up. Okay, so just working with this, we break this down. This is just one term. So I put it here, but it's a quadratic, so we'll have ax plus b in the numerator. This guy is a multiple, so it has a buildup, x plus 1 squared, so that's just going to be c and d because it's linear. Of course, then we're just going to have, I'll set up the next step. Bring our numerator down, 3 is equal to, so this is in a denominator, but if it was all, it's over x squared plus 4, so it's over this. So what's missing? X squared, x plus 1 squared. Plus c, it's over an x plus 1 term, but how many do they have? They have 2 of them. So I need this term and one of these. So in black I'll say x squared plus 4, and I'll also need one of those x plus 1 terms. Continuing on, For D, it has x plus 1 squared, so it has this. I will need x squared plus 4 to complete my numerator. Okay, now just like we've done before, what if I wanted this term to cancel? What would x need to be for me to get a 0 here? Negative 1. Okay, so we can do that step and then afterwards plug that in and then do process of elimination. That's an easy part, but let's go ahead. The next thing we got to do is actually FOIL these out. So we'll FOIL these out and simplify. Okay, so FOIL these here, FOIL these here. That's just brought down, distributed out. Next step, I'm going to have to FOIL these two, then distribute this out, distribute this out. So basically, you're going to get this long chain of things. Now, the next thing we want to do is be able to group like terms. So basically, x cubed terms with x cubed terms. You want to have x squared terms with x squared terms, x terms with x terms, so on and so forth. Okay, grouping like terms, these are the only x cubed terms, your x squared terms, x terms, and then these are what's left. Now, we want to take that in comparison over here. Well, on the left, what's the x cubed term? There is no x cubed term, right? So we would say that would give us a plus c must equal to 0, right? Okay, what about the x squared term that's over here? There is none, so what equation can we get from that? 2a plus b plus c plus d must equal to 0. Okay, what about our x term? Is there an x term on the left? No, so the same thing. So we'll have a plus 2b plus 4c is equal to 0. And then we will have what's left over, this is equal to 3, right? So that's our last one. So we'll have b plus 4c plus 4d is equal to 3. Okay, and at this point you're just going to be solving these systems of equations, which it's easiest to start with this one, and you could just move c to the other side, so a is equal to negative c, and then I would substitute into, I substitute that into this equation. Okay, and then basically just keep substituting back and forth until you work your way to find all of your unknowns. And also don't forget that you have 3/5 for the D. So basically we'll have enough information to just work your way through this algebraically. And what you should finish with, let me see, we should get as our terms to check this, your A term should be negative 6/25. B is negative 9/25. C is positive 6/25. And what do we get for our D? D was 3/5. And then ultimately, you would plug those in up there. Okay, so then you could just rewrite this and work that. So the practice in this was just being able to use partial fraction decomposition there. And like I said, go back. You can go back and do all the algebra to that and finish this out.